about what is calculus. This is how I like to explain it. Tell me if you're down with this. Do you agree? Up through. This line, you agree, we were like, oh, cool. Why? Because mx plus b. Everything prior to calculus was talking about straight lines. And would you know the slope of a straight line? Yeah, the slope of the straight line is always the m, right? And it was constant. This slope was a positive something. What would we say about this slope? Negative something, right? So slope is just a rate, a rise over run, right? So if I was driving to school, my slope or my rate would be, say, if I'm coming up Riverside Drive, I'd say I'm going like 45 miles per hour. Miles per hour was my rate. That's my slope. Was I always going 45 miles an hour the entire time I was driving to school? No. Should I be pulling out of my driveway at 45 miles an hour? We have a problem. I'm probably going to run over a little kid. Okay, that'd be bad. So, is it very real world to have your slope or your rate always constant? No. So then we go into calculus, and Newton was like, this is not really real world to have constant rates, or like my velocity of my car was constant, right? So he was more like, okay, her rate is going to change, meaning that's when he was like, okay, what if this was her function, and then I wanted to know the rate at that point in time? What would you say the slope is at that point, positive or negative? Positive. But then right here, my rate would have been zero. Maybe I was stopped at a stop sign. And then over here, my rate was negative, which just meant maybe I had to turn around and go back because I forgot something at home. So calculus, are we able to find the slope or the rate of this curve, Mr. Heald? Yeah, that's the derivative, right? So that's that fancy word for that rate. And it's just what calculus does is it talks about the slope that we've done for years now, but it just puts it in a real world context because my function or my position isn't always going to be constant, okay? My rate isn't always going to be constant. So that's what makes it just a little harder, because now we're talking about that rate. That rate can always change. The rate could be positive, zero, negative of the same function. So that's what just makes it a whole new ball game. What Unit 4 is all about is instead of just saying, hey, what's x prime, that derivative, now they're going to say, what's the velocity? And you're like, what? So we're just putting a word with the derivative, meaning, let's talk about it right here. If I said, hey, how do I determine the units of the derivative? You guys, derivative we know is just slope. We know, we're like, cool. The derivative is just the slope. And we know slope is just rise over run, right? So you guys, slope is just rise over run. Rise is just that y-axis, right? Run is just that x-axis. So to get the units of f prime are just the units of the f of x, or the y-axis, divided by the units of the x-axis. That's just always how we found the slope units, change in y over change in x. Units of the f of x axis, f of x is just fancy for y, over units of the x-axis. If I'm talking about jelly beans, who's down with some jelly beans? You know I'm down with jelly beans, yeah. So AP wants context now. Instead of us saying f prime, instead of us just saying p prime, they want us to know, they want to make sure that we know that that is a rate. So this is kind of the blueprint, if you will, as when we talk about things in the real world. So let's just look at this example, and then I'll talk about this. So it says a pie is taken out of the oven. We're taking our delicious pumpkin pie out of the oven. The temperature of that pie in degrees Fahrenheit, T minutes after the pie is removed from the oven, is given by P of T. Interpret P prime of 10 equals negative 13 in the context. They want that context. So when it says when they interpret, you better include context of the function, the rate of change, because P prime just means a slope, which is a rate, the value, when it's happening. So they want to know, I'm not going to say it yet because I want you to say it, and the units. What would we say about this? P prime is the rate of change of the
pie
at T equals 10 minutes. The rate is doing what? Increasing or decreasing? Look what they want. They want, is it increasing or decreasing? If this is negative, it's decreasing. If it's positive, it's increasing. 13, it's a rate. So we've got to say degrees, it's a rate per minute. A rate is my miles per hour. It's always going to be something per, right?
Negative 1.3.
We could actually just say, okay, let's start. Ready? It says at x equals, and in this case, it's going to be at t equals 10 minutes. What are we doing? What's the context?
Temperature.
I love that. And can we just use the words that they give us? They literally said the temperature of the pie, please. The temperature of the pie. And are they good with you abbreviating temp for temperature? For sure. The temperature of the pie is doing, look what they said next, is increasing or decreasing? Decreasing. Do they need the word rate? 100%. At a rate of, if we're ever talking about prime, we got to say the word rate. 13. We actually don't have to say the negative since we said the decreasing. That takes care of it. If we put the negative with the decreasing, they would take off because it would be like a negative of a negative. It would make it positive, right? At a rate of 13, what are we going to say our rate is? Yes, degrees Fahrenheit per minute. I'm about to blow your mind. Oh, sorry. I'm about to blow your mind. Check this out. And this one, I'm debating not even doing it, but for some, I'm just going to do it. If you don't get it, just keep moving on. Look what I gave you on this one. The rate at which people enter a water park in hundreds of people per hour is given by W. I already gave you a rate. I really gave you a W prime, you know what I'm saying? But I labeled it W. They can do that. And they said, interpret W prime of 3 equals 2.6. So at T equals 3 hours. That's okay. We don't even have to. At T equals 3. This is the hard part. This is what's going to blow some people's mind. Do you agree W is already a rate? And they want W prime, which is another rate, correct? We have to say the word rate twice. It's ridiculous. So check this out. We'd say the rate, because again, they gave us the words. The rate people entered a water park, Zoombezi Bay, if you will. Do we want to say is increasing or decreasing if it was 2.6? Is increasing. Yes, exactly. She just said at a rate. And you're like, wait, didn't I already say that? You guys, we did. But because they gave us a rate of W and they want W prime, it's another rate and we have to say it twice. Yes, sir.
Can you abbreviate increasing or decreasing?
Yeah, INC or DEC. They're fine with that. At a rate of 2.6. Now let's think about our units. We're talking about the rate of this rate. Hundreds of people per hour, or per hour squared. Very good, you guys. That is really hard. Hundreds of people per hour squared. That is really hard. If you're like, what are you talking about? Don't fret about it. I just wanted to expose you to it once. Here's what I want you to take of 4.2. We're just going to get started on 4.2. We're taking, yes, physics. We're taking our F prime, and our F double prime, and we're just putting words with it. Okay, you guys? The position is always going to be our initial function. Boom. The velocity is just our rate. Look at this. So position is just a unit. Feet, miles, meter. Yes. My velocity is always going to be a rate. It's just my slope. Slope is, say, meters per second, miles per hour. So this is just going to be my F prime. And then finally, the acceleration, if it's meters per second, it's going to be F double prime.
Oh, it's the changes.
Girl, you guys, you know what I didn't tell my other class? Guess what F triple prime is? AP doesn't make you know it. It's the jerk.
I don't
I forgot.
Shh. Here we go. Check this out. Here's what I want us to get in the habit of doing. They said, hey, the position. Go ahead and circle that word because it's important to know what they gave us. The position is x of t. They gave us the position. T is measured in seconds. The function is measured in meters. Find the velocity. You guys, they gave us the position. What do I need to do to that? We just got to find the derivative. All unit 4 is doing is putting a word to the derivative. So it might help you to say x prime is just the velocity. Do you need to write x prime as velocity? No. I just figured on day 1 it might help. Think we can go find x prime?
Yes.
Yeah, what's the derivative of 12 sine of pi over 6t? You got this.
Chain. No.
Yeah, chain.
Okay, so what is it?
12 cos.
12 cosine
Pi over 6.
pi over 6t.
Pi over 6.
Colin, I didn't even have a chance to say you did such a great job in the play. Did we find the derivative of this? Did I leave off the 5?
Yep.
Yeah, because the derivative of 5 is 0. It's the first yes I've gotten from Graham today. Where's this pi over 6 coming from? Chain rule. Very good, you guys. You guys, I said, what's the velocity at t is 6? So now we just got to go say, okay, x prime of 6 is going to be 12. Cosine of pi over 6 times 6. We love to see that, don't we? So it's going to be just the cosine at pi. Cosine at pi
Oh, pi. Negative 1.
is negative 1. So we've got 12 times negative 1 times a pi over 6. 12 sixths. Could I just say that's 2? Final answer? You got it, bud. If I were to ask units, you just found me a velocity, you just found me a rate, what would we say my units are going to be? Perfect, Chloe. Meters per second. If they do not say, oh, I did say indicate units of measure. That's exactly what they'll say. If they don't say that, don't put the units, okay? Here we go. Here I am in my car, and I'm coming out of the driveway. When am I at rest? What do I know about my velocity?
0.
Yeah, so I want us to write that. My velocity is 0, or another way we could write that is we could just say my f prime equals 0. You guys, again, if I start in my garage and I go to the left, what do we think my velocity is going to be? Negative, exactly. So let's say my velocity is negative. Or another way to say that, you don't have to write those words. If you just want to say my f prime is less than 0. That's another way to say negative. What about if I'm moving to the right? Yeah, my velocity is going to be perfect. Or f prime is x is greater than 0. Okay, so let's skip this just for now. Particle moves along the x-axis. And again, we got to circle this. The position is this. Yeah, that's f of x, if you will. When is the particle at rest? If that's what they want. Talk to me, Dicey. Close. When is the particle at rest? We know a particle is at rest when the velocity is 0.
So x prime has to equal 0.
Yeah. So wait, x prime has to equal 0. Exactly. We're looking for x prime equaling 0. Does that help, Dicey?
Yeah.
Okay. Can we find x prime?
Yes.
I feel like at first this is gross, but then you're like, exactly. First this looks nasty, and then you're like, oh wait, she's not the devil. It's okay. Because 1/3 of 3 is going to get me what? 1t to the
Squared.
second minus
5t.
plus
Yeah.
4. So we were just taking that 3 times my third. I did this on purpose, y'all. 2 times my 5 halves. You're welcome. You guys, that's my velocity. We've done this for months now. And now we just have to say, oh, when is that? Ooh, do I plug it in? They said for where t is measured in minutes, when is the particle at rest? They want to know t. So when is it at rest? That's when my velocity is 0. Yeah? If we would have plugged in 0, that would have been what's our velocity at the start when t is 0, and it would have been 4. Okay, what are we doing? We're tooting. What? My root tooting good time. What multiplies to be 4?
No, my sister.
T minus 1, t minus 4 says Lila. -1 times -4 multiplies to be 4, and they add to be a -5. Lila, thank you. What does t equal? Thanks, Lai. So at 1 minute and at 4 minutes, this particle has stopped. The velocity is 0. Cool?
Yes.
So now in your homework packet, you guys, I want us to do page 1 and the first 2 problems on page 2.